Hey everyone, since we don't have class today, I just wanted to give a quick tutorial on creating multi-story buildings with just a simple sketch for anyone that's interested. It's a super quick workflow, so we're just going to dive in real quick and show how this works. So you'll notice here I have two sketches in Rhino, one circle and one curve. And we can use those drawing on the surface to very quickly and simply give us these multi-level skyscraper type structures. They can be any size you want, have as many floors, have different colored glass and different color substructures and densities and everything. So super powerful script and really one that's not too long. So we're just going to go ahead and quickly walk through how that is set up. For this tutorial, you will need these three plugins. So Pufferfish, Lunchbox, and Ngon. They can all be found on the Food for Rhino page. So you can download it from there and follow along. So we're just going to start in Rhino by drawing a curve. You can draw any curve you want. I'm going to start first with just a circle. And then we could also add another offshoot from it to say be another part of this building. Just like that. And the curves can be open, they can be closed. It's not going to matter for this workflow. So we'll start with this first curve to show just how this works. So the first thing we'll do is grab a curve component. Just like anytime we use a curve in Rhino, we have to instance it in Grasshopper itself. So we can grab that curve component, set that curve, and now you'll see that it'll show up in Rhino when we click on it. The next thing we'll do in order to have flat sides that we can add windows to, just for construction purposes, is we can divide up this very smooth curve into a curve with, say, 10 different sides to it. So super easy to do that. We can take the divide curve, and this will divide it into equal length segments. By default, it's 10, so we can leave it there. That'll give us 10 points. To make the flat sections in between the points, all we want to do is draw a line in between all the points. Super easy way to do that is to use the polyline component, this one right here. And this will draw a line between a list of entire points. So we have 10 points here. If we draw the line will go all the way around. You'll see that there's an opening right here. We want to complete it. So there's this other option in polyline called close polyline. We just want to set that to true. So we can grab a toggle component, plug that in to the closed option, and just double click this until it goes true. And you'll see we have a full loop now. The next thing we can do to create like the concrete slab for a floor is with this curve, we can extrude it vertically with this extrude along a single axis. So we can plug in the curve into the base profile curve here. And then all we need to do is give it an extrusion direction. Currently, since we're doing like a building, we always are going to work upwards in the Z direction in Rhino's case. So to extrude on the Z, we can grab a unit Z by just typing Z into the search box. Plug that in, and you'll see this curve will rise up now. We can make this however thick we want. Right now, just for the scale of the base curve that I made, this is a little bit too thick for a concrete slab for a floor in a building. So I'm going to grab a slider from 0.1 to 1. Super simple. Maybe I'll set this to 0.2. Give us a nice thin slab right there. So with this extrusion, we just want to make it solid. So we want to add top face and a bottom face. There's a component called cap, which super simply will just cap any open holes on a B-rep. This is a B-rep since it's a curve to a surface. It's not a mesh. It's not a sub-D. And if we hover over the extrusion here, you see we're getting a B-rep. So cap holes only works with B-reps, and it usually does its best job when it has to close a flat surface. So any curved surfaces might be harder, but since this is two flat curves, if we plug that in, we can get those two top and bottom surfaces super easily. And you'll see now we have a closed B-rep. So now what we can do is create the multi-stories of this structure. And again, super easy way to do that. We can just create a linear array. So in a linear, so in one direction going up, we just want to create many different floors. So we can grab the linear array component, And this has 3 inputs here. The first one will be the geometry. So we have the base geometry. You'll see it's already starting to do something, but it's creating the array in a wrong direction. The next option is the direction here, and you can see right now it's moving on the x-axis. We want to go vertically again on the z. So I'll grab another unit z, plug that in. We're going in the right direction now, but again, for this scale, I might want to go a little bit bigger instead of 1. So I'm going to create actually what's in the factory. Yeah, so we can create maybe a slider from 1 to 10. Plug this in, and now we can control our floor size. So I'll just leave it here for the minute. The next thing we can do is set the number of floors. So we don't have to just have 10. We can have as many as we want. So I'm going to create another slider from maybe 10 to 30. So we can set the number of floors at our whim. So now we can have a lot of different floors. I'll just stick right here to 16. So that's for the floors. Next thing we can create is the windows itself that wrap around the structure. So what we can do here is, first thing we'll do is want to figure out where to place the windows. So we have this base polyline here, and say we want to add maybe 3 windows per face or side of this curve. What we can do is, first thing, let me hide all this. So we have these 10 sections here, and since it's a polyline, it knows that there's a break in between each of the sides right here. And one way to get the single lines out of that is to use the explode, and this will explode a curve into smaller segments, as it says. And we don't have to set a value here. It'll just take any kink in the line, so where this vertex is, and pop out a section for us. So now we have 10 lines or sections of this curve. Now that we have these lines, and you can see, I use this all the time, is if we grab a list item, this will just show us a single item in the list. So since there's 10 curves here, this will show us the first curve since the index is set to 0. And we can see that right here, we have that single line. So if we want to divide this into 3 different segments for 3 different windows, what we can do is, again, in the curve tools, there's a shatter component, and this will shatter into segments. So we can plug that single line in to the shatter, and this one, we'll see it does need another input, so the parameters to split at. Since it doesn't have any kinks that it knows where to split, we'll have to tell it where to split. So if we want to split it into 3 segments, what we can do is, instead of typing in, say, 0.33 and then 0.66 to get 3 segments in between, we can just use a range, and the range will give you values within a domain. Right now 0 to 1, which is perfect for us. And this one, we can see it has 11 different numbers. We only want 3 segments, so we can grab a panel with the 2 slashes, type a 3 in, and we'll get a panel with 3. Plug that into N and then T, and then this will be shattered into 3 different segments. Again, if we grab a list item, we can see that we have 1 segment. And if we grab a slider to flip between, we have other segments there. So you can see 1, 2, 3. You'll also notice that the segments are different sizes, which you don't want. We want them to be evenly spaced. The reason why it's doing that is because the curve that's coming in has its own domain, its own length. And right now the range is only going from 0 to 1. So the curve might be longer than that. One thing we can do to fix that is just reparameterize the curve as it comes in. This will set the domain of the curve from 0 to 1. So now you can see in Rhino, when we flip between the 3 numbers, we have 3 evenly sized lines right there. So that just did it for 1 section, since we were only telling it to do this first curve. We want to do this for all of them. So I'm going to get rid of the list item and then just plug the segments right back into the curve where it just was. Now we'll split all 10 sides into 3 different sections, and you can see them all showing up here. 1, 2, 3, as we move between this list item. Cool, so that's all set up. So I'm gonna delete this list item again, we won't need it. We have all the segments that we need here. So one thing we want to think about going through the script is that when we add the metal substructure between the windows and the concrete slabs. They can't be overlapping. We'll need some space between the slab and the window to add that metal substructure. So what we can do to look ahead for that is to move these windows away from this wall, from this base curve. Super simple, we can just offset the curve, and then I'll just move it away from itself a specified distance. So we can see if we plug the curve in there, we'll get an offset of a default of 1, but we can change that default. I'm going to do something smaller, grab a panel of 0.2, but this can be any size you want. So now that we have the offset, we already have the shattering set up to get the different windows. So we can just trade the polyline for this offset polyline as it goes in. And now we'll be creating window sections on this offset curve. So that's good setup to go. Next thing we'll do, just for visual sake, is if we have 3 windows on a line of those 3 segments, 1, 2, 3, the windows will be right up against each other. So visually, they might look like a single surface. So I just want to add some extra visual here to delineate that there's 3 windows. And one way we can do that is to scale down each section just a tiny bit to give it some distance between the windows. So as we've done in the past to scale things down, we can grab the scale component. Since we have those 3 sections of each curve, if we scale it, right now it'll be scaling around the center of scaling, which right now is this input of 0, 0, 0 of the origin. But we want the center to be the center of each segment. So we scale down the segments within themselves. So super easy way to do that is if we just grab the curve middle. And this will find the middle of each of the curves that we have coming out of the shatter. We can see that we have the middle, 3 middles for each line segment. So we can use those middles for the center. We can use the segments themselves for the thing we're going to scale. And then we can just add a scaling component. We want it to be really small. So 1 is full scale, 0 is super small. So I'm just going to go 0.9. So it scales it down a tiny bit. And you can see that we now have a tiny little gap in between each window segment. So now that we have that, we can scale or extrude up the windows so we have actually flat surfaces that look like windows. So just like when we did the base down here, we can use an extrude again for the windows. Again, we'll be extruding by Z, so the windows are vertical. And I'll just preview these back on so we can see the full building again. And when we extrude up, we'll want to extrude up by the same value that these concrete slabs are offset by so that the window takes up the full amount of space. So we can just use the same Z value that's going for the linear array for the offset here for the windows, and we'll get a full length window. And that window will change its size when we change the height of the slabs. So it's all wired in together. It's pretty nice. Now what we can do is with this linear array, we can use this to make an array for the concrete slabs and an array for the windows at the same time. Really easy way to do that, we'll just pipe both the windows and the slabs into the same input here. And to make things easier for us down the line, we can merge these 2 together, but we'll merge them in a very smart way. In the past, we've used the merge component, and this one's nice, but it doesn't by default keep the orientation of the way you insert things into a list. So at the end, we'll add a color to everything. So we'll want to know where the windows are and where the slabs are so we can add the appropriate color for the windows and the slabs. So instead of using a merge component, we can use a very similar one. It pipes multiple inputs into a single output, but it's called entwine. And this will keep each input on its own separate branch of the list so that we know where they all are later on. So we'll get rid of this O2 one here since we only need 2 inputs. We need 0 and 1. So 0 will be the windows and 1 will be the slabs. So we can plug the slabs into O1 and you'll notice they have a solid line. So they are flat lists. There's 1 closed B rep here. Well, we'll want to mimic the same thing for the windows. Right now we have a lot of branches. So the first thing we'll do is flatten it. Now we have 30 surfaces, but we want to have a single item so that we can keep it all contained in here. And one way we can do that is to just group together all of those 30 windows with the group component. And now we'll have one group. So now that we have one group, I'll plug that into 0, 0. And now coming out of the entwine at branch 0, we'll have one item, and at branch 1, we'll have another single item, which is pretty nice. So now if we plug them both in to the geometry, and I'll just hide everything else, you'll see that we are getting windows and slabs going all the way up. At the top here, you will see we have an extra set of windows that has no roof. It's not too realistic, so we can easily fix that using pretty much the same method with this entwine here, but just with 2 number values for the count. So I'll pull this entwine, and I'll just disconnect both of these inputs. Since we don't need these anymore, we'll have different inputs for the number. So for the number right now, we have a count of 16 going up. But since we have extra windows, we can do a count of 16 for the concrete slabs, but we can do a count of 15 for the windows, so just one less. So with the pufferfish component, there's a really nice option where you can just type in X minus, and we'll get this component that's just X minus 1. You could do this in Grasshopper by just grabbing a subtraction component, adding a 1 to the B and doing the subtraction, but this component does it all for you. So it just takes the 16 and subtracts 1, so we get 15. So again, we'll want 15 for the windows and 16 for the slabs. So we'll have to mimic the structure up here. So windows were coming in on 0, 0, so 15. And the slab was coming in on 0, 1, so that's 16. Again, we'll have 2 branches with a single item. So the organization is still the same as up here. So we can just plug in that number to the count, and you'll see we'll have 1 less layer of windows. So now we have a fully enclosed building. So now getting into the reason why we used flatten instead of merge to keep them on different branches is so we could add different colors to them. So right now, since we have a single list with 2 branches in it, we'll first want to break this list up so we can grab each branch independently to add an independent color to each one. So we can use this component called explode tree. And this will give us the branch of 0, 0 and the branch of 0, 1. So we have the windows and the slabs on these different branches. We turn these off, and right now the next thing we'll grab is a custom preview. So this will allow us to add custom colors to each of the windows and each of the slabs. So I'll grab 2 of them, one for windows, one for slabs. We can also grab this component called color swatch. So we'll have a color for the windows and a color for the slabs. So we can plug the slabs into the preview. They'll pop up, and the windows pop up as well. They come in default as pink, but once we plug in the swatches, the colors will start to change. So for the windows themselves, we could choose a nice window color. I'm just going to give it an alpha value as well to add some transparency to that, so we can see through to the slabs, and then we can add a color for the slabs as well, kind of like a dark gray. So now we're getting there. We're pretty close. The last thing we want to add is just that substructure that'll hold everything up. So the first thing we can add here is, say, some concrete columns within the slabs that hold all the columns up. After we do that, we can add a steel structure, kind of like a waterfall screen right here, just with that steel lattice work in between the windows to hold them on as well. So the first thing we can do if we want to add concrete columns is we can scatter some points within this base surface, make some circles, and extrude those circles up just like the windows. Super, super simple. So the first way to do that is, if we want to scatter some points, we can use populate geometry, but we'll need that geometry to scatter within. So we have the polyline here, and remember this was the base polyline from before with those 10 sides. We can use a component called boundary surface, and this will take a boundary and convert it into a surface. So we have that surface there, and if we plug that into populate, we'll get points scattered randomly within this surface. We might not want 100 points as is the default, You might just want a couple columns, so I'll just do 4. Plug that into the number, and we'll get 4 points scattered within this surface. Now with those points, we can add circles to them to get the columns, and you'll see the columns might be quite big for the scale of building, so I'll add a slider from 0.1 to 1 to give us some variation there. Maybe we'll set it at 0.2, 0.3. Seems good. So now again, we can use extrude to make them go up the entire length of the building. So we can plug those circles in. And now we'll need a Z factor. So the Z in this case can be the number of floors that we have multiplied by the height of each floor. And that'll give us the full height of this column. So we can just grab a multiplication component, and we'll multiply the height of the slab, which is 2, by the number minus 1 of the number of floors, so that the columns again don't go over the height. Add that value of 30 to unit Z to give us a Z vector. Plugging that into the direction there, and we'll get columns that span the full length of our tower. Again, we can cap them to make it into 4 closed V-reps. And then we can add, again, a color to that. We'll just keep this same gray here. Preview that all off, and we'll have 4 gray columns. Last thing we can do is add the substructure, and this one will be using the, I believe it's the Lunchbox plugin. And the Lunchbox plugin is pretty nice. It has all these structures and trusses that you can create really easily with a single surface. So we'll be using those for this script. So for this one, again, we'll take the sides of this base polygon right here that defines the floor outline, and we'll use that to create a truss structure on each of these sides. So we don't want the offsetted curve. We want the curve on the inside so that the truss structure can be between the glass and the concrete slabs. So I'm going to duplicate this explode component and just drag it down here. And instead of having the offset curve be the input, we'll go back a step to the polyline that defines the offset, and we'll use that polyline to explode again. I'm just previewing this off. Now we have the curve back at that original base outline. So with that, we can extrude this all the way up, and that'll give us the surface to create the truss on. So I'll bring this over here, and we can use the same Z for the columns that we'll use for this surface, because we want the truss to go up the same height that the columns, that the slabs do, that the whole building is. So we'll use the extrude component again. So we can extrude these segments based on this Z value, and you'll see we'll have kind of like a 10-sided polygonal extrusion coming all the way up. Not much detail to this, but the next step will add all of the detail. So we can grab a brace grid 2D structure. This will be the truss structure that we'll use. And if we simply plug in the surface there, you'll see we'll instantly get a very complex, detailed truss structure. This might be a little too complex, but we do have these U and V components to play with. So I'm going to add a slider from 0 to 10 here. And we can use this to give us different numbers for U and for V. So I'll plug those both in. I'll keep them at 10 right now, so nothing changes. But as we change these sliders, you'll see that the detail is changing as well. For the trusses, we might want to keep the verticality pretty dense, so we can take away some of that horizontal space to space out the trusses a little bit and give the occupants a little space to see through the windows that are on the other side of these trusses. So coming out of here, I'm going to use a data component just so we can see what's happening. See that lines A is going to be the vertical and horizontal lines that define the pattern. And then line B is going to actually be the trusses within those vertical and horizontal lines. So we want to use lines B, so the truss, the angled lines here to create the trusses. And now from the plugin Ngon, we can use a component called mesh pipe. The reason I use this is because there is a pipe component in Grasshopper, but it's super heavy. If you have a lot of curves like this, it might take a couple more seconds to compute than mesh pipe does. Mesh pipe, we can plug the curves into curve, and in 26 milliseconds, we get an output. So this is usually a lot quicker, a lot lighter on the script to use mesh pipe over Grasshopper's default pipe component. So again, we have a radius value here for the pipes, so we can make them whatever thickness we want. I'm going to go from 0.01 to 0.1. And we'll be able to change the thickness there and make that anything we want. Cool, so now that we have that, I also want to make that a gray color. And instead of duplicating this again, we can just use a merge component. And I don't care about the organization of the columns and the pipes here. It really doesn't matter if we're just adding a color to everything. So we can merge them together, pipe it into the preview, and then displaying that, we'll have the 4 columns and then the outer truss structure. Maybe we'll make it a little bit thinner. Cool, so now that we have all that, we can bring these colors together, and I'll just preview everything back on. So we have that full building again. So this super quickly creates a parametric building that if you change any of these sliders or you change the base curve itself, it'll change how the structure itself looks. We can make it taller, shorter, whatever we want. Next, I'll show a really cool thing to do in Grasshopper if you want to use a script on multiple things. So I have this other curve here that I also want to use. So instead of duplicating all of this and then piping in the other curve, something nice in here is we could use everything we made. Since we don't really need to change this, maybe we could change the height of the structure. So I'll drag that over to the side here. But what we can do is select all the operations that we're doing, select them all green, and then click off to the side, and there's this button here called cluster. And if we click that, it'll merge everything into this single block here. Everything we didn't select will still be outside, and now this just looks like another component, but this is doing the entire structure calculation within it. So we can still change the height of the building. Let me just preview this off so we see the colors. So we can change the height, we can change the curve, so that's something we'll do next. So I'll just duplicate this now, and you can see in the grand scheme of things, this takes up a lot less space than what we had a couple seconds ago. And since we don't really need to change anything inside, if you do, you can explode the cluster, drag the sliders out that you might want to change, and then once they're outside, just cluster up everything on the inside again, and you could have another output here. But right now, I just want to change the height and the curve, basically. So with this second one, I'm going to select this curve in Rhino, come back to this curve on the second instance we have, and just set that curve as well. And we'll get another building instantly being generated for that height. And I'll make this one a little bit shorter. So now we have more dynamic looking skyscraper with multiple different levels, different stories, and they all have different colors here. So we could change this again if we want different window colors for that. So really, really versatile. And also if you had like a Voronoi structure as well, like we've done in previous classes. Just like this, you could also use this script with all those curves as well to give you, say, buildings based on this grid structure. They could all have different heights, different colors and everything like that. Let me just make them a little bit bigger here. I'm just going to grab a single item out of this Voronoi list item, plug it in here. And you can see that now we have this whole, say, a city grid of shapes, and we can add a building to every single shape like that. It can be different heights based on a random value. We could also, say, scale down this structure based on its center point. And now it has maybe a little street access around the building, so that if we put a building in this cell, there would be a little gap in between, and you could do that for the entire cell grid here, which is pretty powerful. So that's the script. I'll put a link to this Grasshopper file as well. So if you don't want to build it, you can just access it. But since we don't have class today, I just put this together for anyone who wants to see it. So hopefully that was helpful and informative, and you maybe use this in some of your projects as well. But yeah, happy scripting.